So today we are going to study about how to find the maxima and minima if there are more than one variable. First we will go through some conditions, then we will solve some questions. So the first condition is that f of xy should be equals to f of yx. F of xy means that the equation fx is derivated with respect to y should be equals to the equation fy which is derivated with respect to x. So let's go through the first order condition. We know that finding the partial derivative with respect to the x and y, we will put it as equals to 0. Okay. Now the second order derivative. Now we consider the second order derivative of x as fxx and y as fyy. So we can see here that it is derivated with partial derivated with respect to x. So d square z upon dx square equals to fxx and d square z upon dy square equals to fyy. Now this is the important and the main rule. Okay. Suppose the second order derivative with respect to x should be more than 0 and the second order derivative with respect to y should also be more than 0, and the sum and the product of both the double derivatives should be more than f square xy. It means that the equation x, derivating it with respect to y and then squaring it. If you don't understand this, we will consider an example ahead, then it would be much simpler. So if these three conditions are satisfied, we can say that it is a minima. If and the second condition is that the double derivative of x should be less than 0 and the double derivative of y should be less than 0, then the product of fxx dot fyy, if it is more than f square xy, then it is a maxima. Okay, so let us consider an example here. Let us take z equals to 2x square plus y square. First we have to find the first order condition for it. First order condition. So with respect to x, we will find it as fx equals to dz upon dx equals to 4x. We will put it as equals to 0. Then fy equals to dz. So here fy equals to dz upon dy, which is equals to 2y equals to 0. Okay. Now we will find the value of x and y from here. We get the value of x as equals to 0 and y as equals to 0. Okay. Now we would find the double derivative. The double derivative with respect to x is denoted as fxx equals to d square z upon dx square. So the double derivative of with respect to x is 4 and the double derivative with respect to y is 2. Now we have to find the product of both of this. Fxx dot fyy is 8. Okay. Now here we look at the earlier condition where we know that if the double derivative is more than 0 and if the double derivative of both is more than 0 such that fxx is more than 0 and fyy is more than 0, then we have to find that if the product of this is more than f square xy, then it is a minima. Minima. Now it satisfies this both condition. Now we have to find this condition to find out whether it is a minima or not. Okay. Now we have find out fxx dot fyy as 8. Now we will find out f square xy. To find out f square xy, this is a bit complicated. So we will take the equation fx and derivate it with respect to y. After derivating it with respect to y, we can see that this equation 4x does not have y, so it is a constant. So it becomes 0 if we derivate it with respect to y. It becomes 0. Now we will also check that the function fy, if we derivate it with respect to x, what's the value? So here it does not contain x, so it is a constant, so it will become 0. So just remember that fxy should always be equals to fyx. Okay, now it is 0. Now we can say that our double derivative of x is more than 0, with respect to x is more than 0, and with respect to y is also more than 0, and the sum of this is also more than 0. Okay, so we will now satisfy this condition. Here we get 8, and if we square this we get 0. So 8 is more than 0. This condition is satisfied. Here it is a minima. Thank you for looking. Just subscribe.